Today I'm going to be talking about the Chinese remainder theorem, which usually for these kind of problems you're going to be given a set of equations, so like my example below, and you want to find the smallest value of x that can make all of these equations true. And so there is a catch. In order to apply this theorem, we have to make sure that every pair of modulars have a GCD of 1, and that's the same thing as saying that they're coprime or they're relatively prime. So let's verify this before we move on. So 3 and 5, their GCD is 1, because that's the greatest common divisor. And then let's check 5 and 7, also GCD 1, 3 and 7, also GCD of 1. So yay, we can apply this. I've also put a little reminder. Whenever I see the congruency symbol, I automatically try to convert it to this formula, just because saying that is not equivalent to this. You can't just substitute an equal sign. So if you're having any trouble thinking this, sometimes it might be easier to convert to this formula. Okay, that's a little unrelated, but I just want to throw that disclaimer in anytime I use the congruency symbol. Okay, so the Chinese remainder theorem is going to be quite a formulaic approach. So this is sort of the fastest formulaic route that I use, and let me just walk you through that. So I always think about this as a sum of 3 large numbers, and the large numbers are going to be based on equation 1, equation 2, and equation 3. Okay, so your first spot is just going to be these numbers here. And let me just fill those in. So that's 2, 3, and 2. All right, that one's easy. So the second value is going to be the modulus of the other 2 equations. So equation 1, we're going to look at, I should have really labeled these. Let me just add in numbers because I don't want to get confused. Okay, so we're going to multiply these 2 numbers together. So equation 2 and 3. So 5 times 7 is 35. Okay, let's do that for all of these. So because we're working with equation 2, we're only going to look at equation 1 and 3. So 3 times 7, and that is 21. Okay, now equation 3, so we're only looking at 1 and 2, that is 3 times 5, which is 15. All right, now what we're going to do is we're going to take the second value that we just calculated, and we are going to mod it by the original mod value. So looking at equation 1, 35 mod by 3 is going to be 2. That took me too long. So let me just write this above so you can see the process. Nope, it's mod 3, and that is 2. Okay, we're going to do this same thing again. Now we're looking at 21 mod 5. This is getting really ugly, but whatever. Okay, and then our last thing, 21 mod 5 is not 5, it is 1. Goodness. Okay, and then we are going to do 15 mod 7. And that is also 1. Okay, and these are all multiplying by each other. Now this just becomes a simple math equation. I've already solved this and plugged it into my calculator, and that's 233. So that is your final answer.